Good morning, everybody. Welcome and thank you so much for joining today. My name is Stephen Trainer and I'll be leading us through the webinar this morning. Today's session is entitled Aligning the Sun, Moon and Milky Way. And the main impetus, I think, for doing the webinar today is that we just introduced some new functionality in Photo Ephemeris Web, which basically builds on the geodetics tools that have been there for years and adds an ability to look at sightlines. So we'll be spending a bit of time looking at that new capability today. But it's broader than that, and this webinar is really intended for anybody who is using Photo Ephemeris Web or the iOS app. A lot of the principles that we'll look at today apply pretty much exactly the same to the use of that app. The iOS app has had a sightline capability for a number of years already, so you may be familiar with that. We'll cover a whole bunch of different tools in the app that help you align your photographs and views with the sun, the moon, and the Milky Way. So with that, let me start my screen share and we will jump in. Okay, that should be shared now. And there we go. And I'm going to come over here. So we're going to start out today in England, in the Lake District. We've got a lot of folks on from Europe, a lot of folks on from North America. It's not a very good time for Asia and Australia, so apologies for that. But we'll start out in a European location in England, and we'll look. I've got three scenarios that I'm going to go through today. We're going to look at something to do with aligning the sun and whether you can see the sun in different locations. Then we'll look at a moon alignment, and for that we'll go over to New York to look at that. And finally, we'll look at the Milky Way shot plan, and for that we're going to go to Utah. So that's the plan. So I'm going to click here, start planning now. Before this is a little tour you can go through if you haven't seen it. It shows you some of the key features. You can always start that anytime with Start Tour up there. So the plan here is we're in England. Let me just zoom out so you can see roughly where we are here. There we go. So this is in the English Lake District, which is in the northwest of the UK. Beautiful spot for landscape photography if you haven't visited previously. And the area we're going to, there's Ambleside, which is one of the better known towns in the lakes. And here is Great Langdale and Little Langdale. And it's a beautiful glacial valley surrounded by fells or rigs. You see all these very interesting names. We don't get many peaks. We get pikes and crags and fells. Those are sort of the names that apply here. And right here towards the end of the road there is a campsite where I have camped a couple of times in the past, and it's a great spot with lots of trails that you can see marked on this. I'm using OpenCycle map here, which is a topographic map, and that's a very good choice for varied terrain like this. It gives you a lot of visual clues as to what's going on in terms of sightlines already. So that's a good place to start. So let's say we were planning to go and visit and camp here in April, so a relatively early season camping trip for England. It might be wet, it's true. Let's jump the date forward a couple of months. So we'll go something like middle of April. Now, here, if you're new to Photo Ephemeris, the basics of it are this. The red pin, you drop where you're at your point of interest. The thick yellowish line here is the angle of sunrise, and that is indicated here in the timeline with the time and the direction. That's a bearing from true north. And here, the deeper orange line is sunset, over here at 8:14 already in April in the north of England. And the blue lines correspond to the moon. This line here is the current position of the moon. You'll see that the time that's selected is 11:13 at night, so the sun is already set. What if we go back to golden hour here? And there's the sun. It's a golden hour. There's no formal scientific definition, but what we use is when the sun is 6 degrees or so above the horizon, and that's when you're going to get nice, rich orange light, better shadows, longer shadows, deeper shadows, those sorts of things. So it's a good time for photography. Question is, are we going to be in the sun down here in the campsite or not? How can we find that out? So let me go through the most basic technique for doing this. All of this is available in the free version of the site, so you will all have access to this technique. So to find that out, we need to know, is the sun behind this ridge line here? You can see from the contours that this is the higher terrain around Beaufell up here, and that the sun is at +6 degrees above the horizon. So the question is that visible or not? So let's find out. We're going to use this tool here, which is called geodetics. You see my tooltip is just off the screen, but it says geodetics. I click that, and what happens is it adds an additional pin to the map. By default, it drops in sort of to the east side of the map, so you'll see it there. It's gray. It's joined to the red pin by this gray line, and then this panel shows up. Now, this may look slightly different than it did as of a week or so ago, and that's because we've added in the Sightline capability, which I will come to shortly. But the basics of the geodetics function are unchanged. So what this is showing is a distance, a direction, a difference in elevation, and an altitude. So let's go through those. First of all, we're going to use this pin. You can click on it, drag it. So there we are. I have the mouse button held down, and I'm dragging the pin. And I'm going to align it roughly with the top here, but I'll just align it with the sun at this time of day, and let go. When you let go, the app will look up the elevation above sea level at this point, and then it does some calculations for the point-to-point distance between the red pin, which we call the primary pin, and the gray pin, the secondary pin. And it shows that distance here. So it's 4.2 kilometers. I'm working in metric because we're in a European country. It gives the azimuth. Now, the azimuth you can think of as, it's the same as the bearing from true north for all intents and purposes. So you can compare the azimuth of the direction from the red pin to the gray pin, 278 and a bit degrees, with the direction of the sun at this time, which is indicated down here in the chart, 278 and a bit degrees. So, of course, they're showing the same direction. And then here's the critical bit of information, the altitude. Just a little bit on terminology in the app. When I use the word altitude, I'm using it in the astronomical sense of an angle. So it's an angle relative to the horizon, like that. So 0 degrees is the horizon. Whether you can see the horizon or not is independent of that. So there might be a hill in the way, there might be a tree in the way, or a building. That doesn't change the definition of the true horizon or the ideal horizon. It's 0 degrees. And the altitude is measured relative to that. So it's +10 degrees from the red pin to the gray pin. So you can immediately see that here the sun is only at 6 degrees, therefore it's blocked at this point by this terrain. And you can spot check a few places here by moving the pin. You can see 10.7 degrees there. As you get closer, of course, the angles become more significant, depending on the contours as the distance shortens. 9 degrees. So the idea of the geodetics tool is that it allows you to check whether a line is visible, given you choose your viewpoint, you choose where you're looking, you can spot check the measurements. Now, if you would like to know more about the geodetics tool, click Help, and there it is. And if you type geodetics and hit return, it'll pop up a link to this tutorial, part 3, and that goes through this tool plus the Sightline tool in a lot of detail with a couple of working practical examples from the field. So you can click there. It shows it in this miniature window, which is a little bit hard to read, but if you click that, it'll open it in a new tab, and you can go through that tutorial. So for geodetics, definitely use those resources there. Now what I'm going to do, I'm going to sign out, and I'm going to sign back in with a different account, which has the Pro tools. So let me just see if I can type my own name correctly. There we go, sign in. And I'll re-enable geodetics. And now we can look at something different. This is the new Sightline tool. So the Sightline tool is basically, as I mentioned before, it's an extension of the geodetics functionality. And what it's doing is it's, instead of just doing a point-to-point check where you need to place the gray pin carefully and pay attention to the contours and do a bit of map reading. You still do map reading with Sightlines, but it's a little bit more forgiving, because you can then drop the gray pin wherever you want and check the visibility. So let me just drop it way over on this descending slope on the far side of Beaufort, and we'll watch what happens. So here we have, let me explain what we're looking at. So there's the red pin on the left. There's the gray pin on the right. You'll see that it's in a sort of a pale gray. And the reason for that is that you can't see the gray pin position from the red pin position. And why can't you see it? Well, it's sort of pretty obvious. There are great hills in the way. We're on the downward slope on the other side, so it's obstructed. And the way this works is it checks multiple points along the sight line. Typically, this is pulling about 150 elevation points along the profile, and it compares the elevation angle of each one to the red pin position and says, can I see this from here or not? I see that this is left in, let me switch this back to I changed accounts and I need to put that back into metric. So there we go. So that is in kilometers and meters now. The solid dark gray line are the segments of the sight line that you can see from the red pin. The dotted areas you can't see because they're obstructed. And as I hover the mouse over here, you can see just above the mouse there, do you see where it says white stones? If I move the mouse, it'll disappear, but basically look here on the line. And then as I move the mouse over the chart, it shows you the corresponding position on the map, so that you can easily relate what's being shown in the sightline to particular features on the map itself. So solid line visible, dotted line here not visible. And you can see there in the chart legend the little crossed out eye icon. So that's indicating not visible. But for each point, it shows you the distance, the elevation, and the altitude angle. In addition, we have this sort of semi-gray area with a solid line, and that's just providing you sort of it's like a marginal area. It might be visible, might not. The elevation data that feeds these sight lines, it's not accurate to the nearest centimeter. It's a lot of this data is sourced from satellites, from space, and there's a little bit of vertical error. So we have a little bit of margin of error built into this, and it gives you a sort of slightly more optimistic view on what might be visible along the sideline or not. So if you see that, that's, yeah, you might just be able to see that, you might not. Important things to think about. This sightline doesn't account for trees, forests, vegetation, or buildings that may obstruct the view along this path. So bear that in mind. There is a way to deal with buildings at the ends of the line, and we'll come to that when we look at the New York scenario shortly. Finally, the other thing you can see is the angle of the sun from the red pin, and it's very obvious that it's too low. We're not going to be able to see it. Let me adjust the time of day, and you'll see as I go earlier in the day, the sun is coming back up. Once the direction of the sun, the azimuth here, gets too far from this line, we don't show it on the chart because it becomes a little bit meaningless. You're not looking at the sight line that would apply to the sun at that angle. So it's limited to within plus or minus 5 degrees when you'll see the sun or the moon or the Milky Way or the galactic center show up in the chart. So let me just go forward again. Here it comes. There it is. And you'll see that even at 7:03, it's too low. It's blocked. And as I go forward, it's getting lower, and yeah, all good. So that's the basic introduction to the Sightline tool. If you are on a smaller screen or you want to just maximize your map, you can collapse it, and it just takes the numerical information away. The tool, the legend is there still, but it's half the height at that point. And then to get rid of it altogether, just disable geodetics, and we're back to the basic view. Let's come back here. Let's say, okay, so we can't see the sun at the campsite, but there's a trail up here. So we could walk from the campsite. I've done this walk a long time ago. You can come up, walk up this ridge line and get to the top of Bowfell, look back along the valley. And there's obviously some other views up here. Now, what I'm going to do, we're going to imagine that instead of sitting in the campsite for the evening, we're going to do this trek. We're going to hike up to the ridge. I'm going to swap the pin positions because I want the red pin up here where we're going to. And then I'm interested to know Scafell Pike. If you're familiar with the lakes, you may well know that Scafell Pike is the highest point in England. It's still not very high. It's 3,210 feet is the number I remember. But we can check that. So let's take the grey pin, drop it up there on Scafell Pike. So a couple of things. I'll zoom in just a couple of levels there. We've established very quickly here that we can see Scafell Pike from the top of Bowfell. This is, we have some latitude in where we position ourselves here, so we can move around a little bit. We can go to that fork in the trail and see that the top of Bowfell, the grey pin is now solid grey. It's dark grey, same as the visible color for the Sightline. And we're looking, this ridge isn't blocking the view. This ridge here isn't blocking the view. I'm not really passing over that ridge, but you get the idea. All visible. Great. What about the sun? Could we shoot the setting sun behind Scafell Pike? Well, you can see that it's looking pretty good even at 7:33. I'm going to click on the thumb of the time slide. If you click on this here, you can either drag it with the mouse, or I'm using the cursor keys on my keyboard, and it advances 10 seconds per click. So I'm just going to zoom through there, and there we go. That is how you can check whether you can align the sun behind Scafell Pike. And this is April 14th. Great. So that seems to work. Hopefully you can see that the new Sightline feature makes it a lot easier than the point to the spot checking with the pin. That said, imagine you were just on the free version of the app. You can still establish that the sun is visible if you've read the map accurately, and you know that Scafell Pike is the highest point, which it is, because we know that it's the highest point in England. You can be pretty sure that with an altitude of 1.67 degrees from the red pin to the grey pin, and comparing that with the sun's altitude, 3 degrees, that the sun is visible. It's fine in this scenario. There are others where it's a little bit more complicated, and you'll see one of those in the tutorial that I mentioned earlier. Remember, click help, search for geodetics, or indeed you can search for Sightline as well. There's a few things will come up for Sightline. There's the tutorial. There's a little overview of the tool. There's a technical note on how it works and so forth, and a few other bits and pieces. But that tutorial goes through a scenario where the spot checking is a little bit trickier. You have to check a few more different places before you can be certain of whether it's correct or not. Okay, so that's scenario number one. That's aligning the sun. We're just using manual tools where we're manually setting the date. You can keep changing the date a little bit here. So we go a week later or so, and you can see that then to get the alignment, you would need to come earlier in the day. Or I'd need, a little bit earlier. There you go. And you can see that, in fact, there's still a bit of a gap. The sun is well above the top of Scafell Pike. So you might say, well, maybe I want to come I need the sun a little bit later, but I can't go south. I can't position myself further south because then I'm walking down an unmarked. There's no trail. I'm walking down the side of the peak. Probably not the best idea in the evening. So it's sort of telling you that maybe the better time to do this is earlier in April rather than later. What if we come a few days earlier again, back to April 9th? There you can see you have to go later in the day. So let's do that. Click on there. I'm using the cursor keys to advance the time. And that's a little bit too early. So it's not quite aligned and it's already down below the top of the pike. So this is how you can use manual tools, checking different dates and see when the optimal time would be to try to get that shot. So far, so good. I'm going to turn this off and we're going to turn our attention now to our second scenario, which is New York. To do that, I'm going to switch in settings. I'm going to switch over to Imperial, so feet and inches. And let me show you the sort of thing we want to try to plan. Okay. This is an article from 2012 when there was a quote supermoon. So a perigee full moon. The moon is at a close point in its orbit to Earth, so it appears larger in the sky. And it's about, if you compare it with the smallest moon, it's about 14% bigger in diameter and about 30% bigger in area, which I think is always interesting. As photographers, if you're thinking about the number of pixels in your frame that will be occupied by the moon, you can get 30% more at perigee than you can at apogee, and apogee is when it's at its smallest. So this was a shot that a lot of people went to photograph this. Here we have a full moon behind the Empire State Building, photographed from Eagle Rock Reservation, West Orange, New Jersey. I've used this location before in a webinar. And it's a really interesting one to look at. So let's take a look. I'm going to load up my my link. Copy that. Paste that in here. And there we are. Now let's just jump in. Get rid of that. And I'm going to switch this to, let's use this atlas map. It's a bit cleaner looking. The open cycle map is just an interesting one. It's pretty busy because it's showing sort of cycling routes. That's what this, sometimes we get people writing and asking, what is ECG on the map? And I had to do a bit of research to find out. And it's I think it's the East Coast Greenway or something like that. It's a cycling route because this was designed as a cycling map. So this atlas map is got a cleaner look. Here we are in West Orange, New Jersey, about 14 miles out of Manhattan to the west, slightly to the northwest. And in fact, if I put on, I'm going to switch to Google Maps, you can see here that there is a little observation deck, it's called, and you can use Street View if you wish. Drop that there and check out the view. That's a little bit set away from, this is where we want to be over here. There you go. So this is Manhattan over in this direction here. So it's a great spot for views over Manhattan from a distance. So let's go. I'll just put the Google Street road map on, and let's look at the shot setup. So I have the gray pin dropped on the location of the Empire State Building, and a couple of things to note. Here we're using the sightline, and you can see the red pin is up here, and then it falls away. So we're elevated. You can see that from the sightline there, and we track across New Jersey. We get to Hoboken here, and there's a little bit of a ridge there. Then we're into the river, and then we're into Manhattan. Now, have a look at this gray pin here, or the gray pin indicator on the sightline chart. You'll see it's way up in the air. Why is that? That is because when I saved the link for this shot, I put in a building height. And the building height functionality is part of the Pro package. If you click this little edit button here, you can enter an elevation offset for the red pin, and you can enter an elevation offset for the gray pin. So I've put in 5 feet, which is sort of the default, assuming your camera's set on an average height tripod. 5 feet above the ground there makes a tiny, tiny bit of difference, not usually very significant, certainly not over these distances. Becomes more important if you're very close to your subject, obviously. And then an elevation offset of 1,454 feet, which a quick Google search will tell you is the height of the Empire State to the tip of the mast. So that's what I plumbed in there, and it shows here. So red pin plus 5 feet, grey pin plus 1,454 feet, and it applies that elevation offset in the elevation profile so that it will show you whether that spot is visible above the ground. So the sightline not only shows you visibility just above flat terrain, but as I mentioned earlier, this is where you can account for buildings, or indeed, if you were doing drone photography and you said, I want to fly my drone at 300 feet above the ground, what will happen to the sightline? Let me show you that just quickly. It's quite interesting. Watch what happens in this middle part of the sightline. Let's say I put 300. I have no idea if it's legal to fly a drone at 300 feet above the ground in this location. Do your own research. There it is, 300 feet above the ground, and now a lot of that sightline there is filled in. It's now visible because we're further elevated above the ground. So that's how you can use these elevation offsets. Let's go back to 5 feet. And there you see it's no longer visible. So the question is, we want a full moon aligned behind the top of the Empire State Building. How can we do it? There are a few different approaches. If I go to the events list and I pick the next upcoming full moon, Saturday the 24th of April, and I'm going to go the day before because it's usually better the day before full moon. So the 23rd, and I click moonrise. That ain't going to work. The moon is rising up here. It's way off. So this is a situation where it depends on your photographic goals. If you're saying, I'd like to go out and photograph every single full moon that I can, then you're going to have to work with the circumstances of that particular moonrise, look at the angles, and then work out, well, what are the potential shots that could agree with this alignment? So for a big moonrise, big telephoto moonrise shot, you're looking for it to be low above the horizon, probably as little as half a degree, 1 degree. So it's really the minutes after moonrise. That's when you get that beautiful orange look that you see in so many of these shots, that you might have seen in the little header image I put in the registration for this webinar. In fact, because of the atmosphere, you get the horizon effects, you get the opportunity to juxtapose the moon against buildings and so forth. So you're going to work with the circumstances of the moonrise. So this particular shot, west orange to the Empire State, is not a possibility. But let's say when you want to know when is it a possibility, how can we find that out? Here we're going to jump into this 3D page. This was formerly called the sphere page. It's now just called 3D for brevity, and I'm going to jump over there and let's have a look at what we have. So this is showing us, there's the red pin in the center of the disk. I can use 2 fingers on my trackpad to zoom in. If I hold the shift key down and drag, I can pan this around a little bit just so we can see what's going on. If I take 2 fingers on the trackpad and push up, that's the zoom in and out. If I click down and drag, I can tilt. If I drag left, I can rotate. And so let's just have a look at it sort of in the reverse. So you can see there's a building representing the height of the Empire State, 1,454 feet. And the red pin is over here, and you can just about make it out. If I advance the time a little bit, you sort of get the shadows. There's the shadow creeping across as the sun sets. So you can see the light sort of catching this ridge here. It's not like the Rockies, but it's definitely there. It's a real feature. And there are a couple of approaches you can take to this. You can just step through different full moons and see, are there any that are close? You can do that. It's not the most efficient way to do it. I'll click the March full moon. I'll go back a day. I'll come over here to moonrise. Again, it's not really going to work. It's a bit too far away. Just make the moon a little larger there. Throw a bit of light on the scene. Not going to work. So how can I find out the date when this shot next will work? We know it worked in 2012, but what about the next time? To do that, I'm going to switch on this button here, which is the visual search tool. And visual search is really intended for this exact question. I know what shot I would like. When can I get it? For the sun, it's generally easier because the sun moves predictably from day to day within certain limits. So it's sort of easier to step through the seasons. You generally know that as you approach the height of summer, it's rising and setting further north and further south in winter. The moon is not like that, so it's harder to work that out. So I'm going to search for the moon. I'm going to search over a period of 2 years. I'm going to uncheck this range option. There are two ways of using the targeting. You can either say, find it within this window in the sky. That's what this thing here is. This little window is the target window. So for example, if I change that to 12 and I change that to 90, you'll see how that little search window updates. But we're not going to use that in exactly this form. We're going to uncheck that. And then we're going to use, it gives you just a single target position in the sky. So I want it right there. And then with a tolerance in degrees. So for the moon, because I'm looking to get the moon behind the top of the Empire State, I'm going to make that 0.25 of a degree, which is about as small as you're going to be able to make it. And then to set the altitude and the azimuth, rather than try to work out what it is and type it in, I'm just going to click Use Geodetics. And when I click Use Geodetics, it takes the altitude that was calculated in the geodetics calculation and the azimuth there, and puts them in as the target. And so when I zoom in here, if I just get that just there, you'll see that there's the target window right behind the top of the Empire State. And so now I'm ready to do my search. So let me click Search. And it gives you the results that match that criteria within the tolerance that you've specified. And it indicates that here we are on July 23rd of this year, 10:14 at night, a 90% full moon will be about 94 feet off target. So it's at the right altitude. We can make this 0.1. So I click that result and it changed the date and the time to match. And there you can see the moon is right there behind the top of the Empire State. Let's come back to the map page for a second, and here we have the moon, and also that vertical bar gives you an indication of the size of the moon, the apparent size of the moon, I should say. The moon isn't changing its size, but how big it looks relative to an object at this distance. And the principle here is that the farther away you are from the subject, the bigger the moon or the sun will appear relative to it. You've probably seen people post wonderful photographs of alignments, and there'll always be somebody who says, "Oh, that's ridiculous, it's photoshopped, it's not possible." And they're just not thinking clearly about what's happening. If you imagine you took a very long hike from New Jersey out from the shore here of Hoboken way out to West Orange. If you keep turn, and every half a mile you turn around, you look at the Empire State, you look at the moon. The Empire State is getting smaller. The moon is not getting smaller because we're so far away from it. It looks exactly the same size, whether we're standing here or whether we're standing there. So what that means is that when you're 14 miles away, as we are here, and then you look back at the at the Empire State. The Empire State is tiny, and the moon is the same size. If you then take a telephoto lens pointed at that subject, 500, 600 millimeters, or 400 with a teleconverter, whatever it might be, that's when you get the giant moons. And so this indication here shows you how big it's going to appear. You can also, down here in the legend, you can toggle that little button there, and it shows you the same things numerically. So it shows you the size, 692 feet across, and it shows you the apparent height above the ground. So that is doing a moon alignment. Next one, we're going to talk about the Milky Way. We'll do a little bit more discussion of sightlines as part of this. I want to show you a photograph first of all. So this was a photo I took a few years ago. It's in an area called Castle Valley in Utah, near the town of Moab. And it is that classic Southwest sandstone, deserty look, sagebrush, with the added benefit of some lovely snow-capped mountains with a bit of light on them. This was taken in March, and if any of you are enjoy running as well, I went here a number of times because they run 2 half marathons in this valley. Not this road, but there's a road that sort of runs parallel, sort of behind the frame here. And you can run from this valley into the town of Moab, or you can run from further up the valley to halfway down the valley through all this amazing scenery. So they run in March and September, I think. And I wanted to look at this shot because A, it's got an interesting question of the sight line. And then B, it's an interesting place to do night photography because the skies are pretty dark. You can find darker skies than this, I will tell you, because Moab is off here, off to the right, and you get a little bit of light pollution from that. And so let me load up this location. I have it saved. Here we go. Okay, so jump in. Get rid of that. I'm going to switch to a different map type. We're back into sort of rugged terrain again, so I'm going to use a topographic map. I'm going to use this one, which is a nice one, open topo map. Let me collapse this down, and we'll zoom in a little bit. So I'll zoom out so you know where you are to begin with. Here is the US. Here's Colorado, here's Utah, there's Las Vegas, Los Angeles, sort of places that pretty much everybody will know. And this is southern Utah here. And the town of Moab is somewhere down here somewhere. I don't know why it's not marked. It's just find a different map. There's Moab. Yeah, there it is. Go back to OpenTopo though. It's a nice map. And we're in this valley here. So as I zoom in, you start to see some of that nice relief shown in this topographic map. Topographic maps are great. You can get so much information just by looking at them. But there are some things that are a little bit tricky to answer. So I've set this up already with, I'm going to show you one other thing. Let's just go to switch Google Maps on, and just because we can, now you can't always do this, but in this situation there is street views available, and if I spin it around, there's the view I'm talking about. Zoom it in. That's the shot. Same shot here. And so definitely use Google Maps in planning your sightlines and alignments. Use Street View is what I mean. It's very, very useful. But oftentimes you're going to be in a location where there is no Street View imagery. So that's when you would turn to these other tools and look at the sightline type analysis. So I put the gray pin behind the mountains here. I just put it sort of slightly randomly along the right alignment, but behind the summits. And when I expand that, this is an interesting example in reading a sightline. One of the things as you become familiar with this tool, I would suggest that you pick an area that you know quite well, a view that you know well, and set up the sightline and then look at it and try to relate what it's showing you with what you know you can see or what you have from a reference photograph to compare with. Just jumping back to the shot for a second, there's so much going on here that sometimes in your head you think, well, I remember the view and the sightline shouldn't look like that. But you have to remember that it's literally one section from where you're standing, one line through the direction that you've selected. So it may not immediately correspond with exactly what your mental model is telling you it should. But that's where you can use some of these tools and say, well, here, this is all visible, which we know it is. That's the stretch of road, which descends slightly. You can see there the altitude of minus 0.83 degrees in the chart legend. And then there's a little bit where it's not so visible, and then the ground starts rising again. And this here, let me zoom in, you'll see that that corresponds, as you'd expect, with the steep rise to the top of Adobe Mesa here, which is what we're looking at right there. So it's useful just to spend a bit of time, becoming used to reading the sightlines. What we're going to do for this scenario is the goal is to see, can we get the galactic center, the center of the Milky Way, over this this mountain summit at some point. And the Milky Way is sort of it's a different beast. If you're used to doing night photography, a few things to note. The Milky Way is a band. We live towards the edge of it. You can look around and see more or less continuous stars in a band. So you'll hear reference to the band of the Milky Way. It's generally considered that some parts of it are more photographically attractive than others. And generally speaking, the most photographically attractive part is that located near to the center of the galaxy, the galactic center. And that is what we can align using Photo Ephemeris. So let me show you how to do that. What I'm going to do, I'm going to turn the Milky Way on. This is available with the Pro plan. It adds more lines to the map. What I might do, I might just turn the sun off just to clear things up a little bit. And I will collapse that and I'll just show you what we're seeing. So we're in February and we have these two lines in the chart. So the gray line, this gray box here, is the galactic center. And you can see that this line here shows the direction to the galactic center. And 8:36 in the morning, it's more or less due south. All well and good, doesn't matter, it's not visible, it's in the middle of the day. So if you've done much photography with the Milky Way, you'll know that the summer, for the Northern Hemisphere, the summer is sort of the Milky Way season. So let's go to the 1st of June, and then you can see, it's moved back in time. And so it's due south at sort of 2 in the morning. And if I come back here, it's getting close to being aligned. I'll come back to the end of the day where we are. It doesn't quite do it, but it's close. So you can do manual alignments like that. You obviously need to check the vertical alignment, the vertical visibility as well. But the galactic center is a big feature. Even if you can't see the exact spot, you'll see something adjacent to it. So let's look at how we can explore that a little bit. We're going to come back here into the 3D tool. I'm going to do one thing though before I do that. What I would like is to put the pin on the limit of the sightline, which is here. See where I'm hovering? See, anything beyond there we can't see from my shooting location, but from there we can see it. So I'm just going to move this pin back a little bit to there. And that's more or less there, maybe just a tad further. And you'll see why I'm doing that shortly. So that's the pin more or less at the limit of the sightline. Come to 3D. Let me just turn this off a little bit and I'll show you what we get. So in the 3D page, there are a few aspects to aligning the Milky Way. It's not just a question of where is one point, because you also have to consider the band. And so one of the things that you can do in the 3D page here is it will show you a symbolic representation of the band of the Milky Way relative to the terrain. And so if I go there, you can see where that is. There's the limit of our sight line. There's the galactic center, the largest of these symbolic spheres, and the arch is going to appear across the frame, sort of from lower right to upper left. We can use visual search for the Milky Way as well. I'll show you how to do that. The Milky Way, again, or the galactic center. It's one of those things that probably you can do a lot of this work manually, but it might be useful to use this visual search just to give you a quick range of dates and times. So I'm going to use geodetics, and I'm going to broaden out my range a little bit here because I feel like we could be a bit more flexible. I'm going to lift that a little bit higher because I don't want it too low. That could go maybe to 12 degrees. And this could come to, let's say, 135 to 150, or even 155. So then I have this much broader window in which I'm looking to get the galactic center. And I'm starting from the 1st of June, search for 6 months. I'll search. And basically you can see that it sort of happens every day during the season, or the 6-month period we've highlighted. But the time at which you're going to get the shot keeps changing. Let's just look at, for example, July 4th. So there it is. Oh, that's a meteor shower that's occurring then as well. It shows up. That's the radiant point of the meteors. But there's the galactic center, and it's within our window, the search window that we specified, and you can make that as tight or as broad as you wish. It's tracking across the window, and you can see that you've got roughly an hour of shooting time from 8:36 to 9:23, where it's within the range that you specified. So that's one of the differences in visual search. If you keep range checked, the results will tell you how long you've got with your target in the window. However, there are a few other considerations for this shot, and it'll only work when it's dark. And because we've got this wonderful view here, with a long exposure, you can probably get quite a lot of detail and foreground in the shot, but you'll need a little bit of light on it, which we can get from the moon. So the next question is, out of these 181 days where this does line up, which are the ones that actually work? And this is where you would come and use the filters. So there's a few things you can use. You can say either just give me astronomical twilight. So I click this suggested filter, and it adds, I want the sun to be between -18 and -12. Or I can say, give me total darkness, which is -90 to -18. -18 degrees constitutes the hours of complete darkness. 18 to 12 is called astronomical twilight. That's when the Milky Way and other deep sky objects are beginning to become visible, but there's still a little bit of residual light in the sky. You're probably not going to get a good shot of the Milky Way during nautical twilight or civil twilight, and you're not going to see it, of course, during daylight. So generally, this is why we suggest these filters. But let's just say we want the sun to be between -90 and -15. You can specify your own parameters there, and we'll apply that. So that's taken us back down to only 18 days that will work. So let's see what we have. And in fact, July, not so good. The sky's not, it's happening too early. You can see these times are getting earlier. So June is the time to do this. Let's have a look at Sunday, the 9th of June. Okay, that's good. Now we can also see here, this blue line here is the moon. So we have a moon off to the northwest, and the moon is 14%, so there's not a ton of light coming from the moon. So let's just see if we can add another filter. We could say we want a completely moonless night. That's another thing you can do. You can say, I want the moon to be out the way, gone, nothing. Or I'll get rid of that. Let's say we want the moon illuminated fraction to be, but we don't want a full moon because that's going to compromise things, but we want it between 0.25 and 0.5. I have no idea if there are any of these results, by the way. I haven't checked this before. So let's find out. I'm going to apply that. We get 3 results. The 11th, 12th, 13th of June. Let's have a look at that. Okay. So this could work. We've got the galactic center in our target window. We know we can see it. We've checked the sight line there. We know the sun is dark, so the sky is otherwise dark, but we have a 40% moon that is up here to the west to illuminate the scene. And that's how you can combine a whole load of these tools to say, give me the right conditions for different sorts of alignment shots. If you were to click, let's say, the 1049, that will move the time to the end of the window, and you can see that one actually puts the galactic center directly above the summit of the mountain. Now, it might be a little bit distant from it, but it's fine. It's not particularly a problem. The way the Milky Way changes over time, it doesn't really move its position. It changes. It stays in the same. If you're located here, this is where it's going to be. You can't really affect that in the way that you can with the sun and the moon. It pops up in the same place in the sky on the celestial sphere, but the time at which it appears is what changes. So that's what you're looking to control here. Plus, you're looking to filter against the sun and moon position to get the right lighting for the shot. If I click there, that takes us back to the start of the window, and then you can also, of course, use these tools to advance like that. So that's pretty much all the material I wanted to cover today. Just as a quick recap, we looked at using the basic geodetics tool to do point-to-point checks for check visibility, check altitude differences, check alignments with the sun. We looked at the sightline functionality. Hopefully, you can see how much easier this makes using geodetics to check particular viewpoints and also get yourself set up for alignments with visual search. We looked at building heights. Remember adding elevation offsets to the red pin or the gray pin. For the purposes of shooting from the 30th floor of a skyscraper, you could put an elevation offset in there, or shooting a building or a hot air balloon that's flying at 1,000 feet above the ground, whatever it might be. You can use that. And then we've looked in some detail at the 3D sphere and also at visual search, filters, and how to use the different parameters within there. So I will now step over and take a look at your questions and see what I can answer. So if you have questions, type them in now, and I'll see what I can get through here. Chip asks, in the New York City example, how did the geodetic display pick up the diameter of the moon? Was that because you'd used the search function in the 3D window? It wasn't actually, Chip. Let me go back to that quickly. It'll work out. I'm just going to pop this in here. I'm going to drop the pin anywhere we want. I'm going to get to moonrise, and I'll put it in there. Let me just go back a few minutes. So that height. First of all, the software calculates what's called the semi-diameter of the moon, so half its radius, but astronomers use the term semi-diameter. I don't know why. So it varies over time because it's moving in and out with this orbit. So we calculate the exact semi-diameter for that instant in time, and then it's really just a question of doing a little bit of geometry or trigonometry to to convert that into an apparent height at a certain distance. So you don't need to type anything in to do it. It'll do it automatically. It wouldn't matter whether I had a building height in there or not. I'll just clear that out. It rescales things a little bit, of course, when I do that. But if I just reverse back the time there, you see it's still showing it there. The reason it looks so much larger is because the scale changed. This is showing a smaller scale than it was before, which is why it now looks larger. It's actually the same number as it was before, which you can see there, 688 feet. So that's that one. Hopefully that answers your question, Chip. Yeah. So Aberdeen says, just a comment. Perhaps having the Milky Way lines in a different color could be better. You may be right. It's a lot of changes, but magenta though I wouldn't use, because that's what I use for the solar eclipse that I told you I wouldn't talk about today. But I'll just show you how that shows up, just so you can see how. That's where I'm using that pink, chromospheric pink is what I'm calling it. So that pops up there. Scott asks, what map does the red pin use, and will it change with different map layers? So the answer to that, Scott, is there is no correlation between the map pin and the map type that you're displaying. If I open this little button at the top left, shows the available map types. They're grouped into two sections, what I'm calling default maps and Google Maps. If you have the free product, you get access to these first three: Open Cycle Map Topo, Neighborhood, which is like a street map, and Atlas, which is another type of street map. So we can look at those, and you can change these map types independently of doing anything with the red pin. So choose the one that's best for your application. If you are in a city, then if you're doing urban photography, you probably want to use something like Neighborhood. But for here, for example, out in the countryside, this is somewhere in northern Mexico where there's a bit of terrain, and you're saying what's going on here, then a topographic map is almost certainly a better choice. And then if you want satellite maps or other map types, for example, the Open Topo one that I mentioned, the Mapbox Satellite or Google Maps, that's available with the Pro subscription, as indeed all the other map types are available with that as well. Okay. Thomas says the sun diameter is easy, 10 meters per kilometer. That's interesting. I hadn't come across that one before, Thomas. That's a good little. I just think it's great it's great having tools like Photo Ephemeris that will work out the stuff for you, but having key numbers in your head can be super helpful when you're planning or just wanting to work quickly and instinctively. So if the apparent size of the sun is 10 meters per kilometer from your subject. So somebody can work out what that is in feet and miles, I'm sure. Thanks for that, Thomas. Thomas says the moon is the same. The moon is roughly the same. That is correct. It's the same to all intents and purposes, within plus or minus 14%, or plus or minus 7% of size, because it does vary from perigee to apogee. But yeah, that's great. Greg asked, is there a way to optionally minimize the upper part of the GUI? Yes. Click this button here. There you go. So that little button at the top right of the map will get rid of all of the Chrome and menus and what have you. The other thing you can do, you can choose what to show below the map. So I can just get rid of all of that and just be working with maps. You still have the time slider here and the data controls, so you can move around. And choose your events or your search, and then if you need to hop around pages, just disable that. And you can say, for example, just show the chart or just show the timeline, like that. Yeah. Good. Well, that is the end of the questions. So don't forget, after this survey, please fill out the survey, and please join us on the forum. We'd love to have you there. We'd love to have your contributions, your questions, your suggestions, and please share any shots that you get where TP's helped. We'd love to see them. And I'll send out an email. A couple of weeks' time, we'll do a solar eclipse webinar, Saturday, the 24th of February. Thank you so much for joining, and until next time, thanks. Bye-bye.